Hi everyone, this video is all about AWS IAM. This is one of the big topic in AWS Solution Architect exam. So I'm going to mention potential area where you will get the question in the exam while going through the video. Of course, end of this video you will get a better understanding of what is IAM and its power. Going to be a lots of demo to understand the theory. All the source code will be in GitHub and the links are in the description section. So as usual, if you like this content and video, please like and subscribe, really appreciate it. Alright, let's get into work. What's AWS IAM? IAM stands for Identity Access Management. This is all about authentication and authorization. Whenever you request to access any AWS resources, the request goes through the IAM service. First, it checks the request is initiated by the AWS user, which is called authentication. If the authentication is a success, then it's evaluate the request user has a permission to do the action on the resource. That is called authorization. In this case, the action could be upload object to S3 and the resource is S3 bucket. There are some exceptional cases where the request is initiated by the person is not an AWS user, but still the person can access the resources. So for example, the access in the object in S3. So we can generate a URL called pre-signed URL, which is temporary and it's come with the expired time. So we can use this URL, the pre-signed URL, to access the AWS S3 bucket even for the non-AWS user. We will do this scenario in a demo during this video. This is the agenda for the video. I'm going through this from some of the basic element to advanced topic. Of course, it's not limited to this topic only. I will talk about some edge cases while going through this video. We do a theory followed by lots of demo. The demo are the best way to understand the concept theory, which definitely help you to answer question in IAM area in your AWS exam. So starting from what are the users, policy, role, and groups. And these are the basic element of the IAM service, but powerful. Of course, you need to know. Then the authentication method. There are many ways to access the AWS. So for example, if you access the AWS console, you can use the username password, or otherwise you need to access the AWS in programmatic way, you can use CLI. And sometimes if you want to do the SSH into EC2 instance, you can use a certificate, and plus if you're working with the code pipeline, you can use the SSH key to code commit. So we will do this in a demo. After that, we are talking about various type of policy. As you can see, there are many type of policies in IAM service. We will go through each with the demo. Then we talk about SCP and permission boundary. So the SCP stand for Service Control Policy. Please make sure these are the big topics in AWS Solution Architect professional exam. If you are planning to sit for the exam, this video will definitely help. And this is, of course, this is my personal experience as I went through the exam the last week. Furthermore, we are going through the how the cross account access work, how to enable list policy to access resources in different AWS account, and lastly, access control policies such as RBAC and ABAC. We will do in-depth a demo. So what is RBAC and what is ABAC, the access control. So there is lots of demo in this video, and stay with me. How IAM work. As you can see in this image, the AWS services can be accessed through a different way. It could be a console, CLI, or API. Let's say the John, he's an AWS user, want to download object from S3. The request first goes to the IAM service, then which evaluate the requester, then it evaluate request is a valid principal. So as you can see, the principal could be user or role or federated login. Federated login is something like a Facebook or Google, or eventually it could be some custom application. If the request is not a valid principal, the IAM service send us 401, which is unauthenticated response to the requester. Let's say the John is a valid principal. Then the request will be further processed against a defined policy. A policy is like a JSON object which define who has what. The example, the policy could be defined: John has a permission to get object in S3, but John doesn't have permission to delete object in S3. These are the things defined in a policy. I'll show you some sample in when it goes to the demo. So again, there could be two policies like identity policy or resource based policy, and we will dig more about this policy again in the demo, so then you get a better idea. Let's say the policy says that John has access to S3, so that it send a success response back to the John. So otherwise, if he doesn't have a permission to access the S3 bucket, it's give a 403, which is unauthorized response to John. So this is how IAM work in a high level. Right, let's talk about the users, policy, roles, and group. User is an account for a single user. Whenever you create a user, by default there's no permission at all. That means the user is able to log into the AWS, but the users are not able to access any resources. By default, 5,000 user accounts are allowed per AWS account. Then if you come to the policy is breakdown to mainly two: permission policy and trust policy. The permission policy further breakdown: one is identity based, which is applied to principal, users, roles, group, and the other one is resource based, which is applied to resources like S3 or DynamoDB. The trust policy is the other end. Whenever the user assume a role, then trust policy get applied. So we will talk about this when we come to the STS, which is a secure token service, and you get a better idea. The next one is a role and groups. I think it's better to show in the AWS console, so you will get a better understanding what does it look like and how they apply. So let's go to the AWS console and see what's in there. Right, so I'm in the AWS console. What we're going to show in this demo: we create user, add some identity based permission, a resource based permission, create a roles, add groups, and sort of thing. So you will get a better understanding how all these elements interact and work together. Let's type IAM in console search, and click on the users. So this is the screen where you can do all the functionality under IAM service. So what we're going to focus on the access management. This is the left side menu, and you can see we can create a group, users, role, and policies. What we're going to do, we will create a user, add a user, new user, give it a name, and you need to give a console access. Otherwise you can't, and this user can't access the console itself. Give name, and I put the password, give it a custom password, and I don't want to change the password in next login. And see, you can see the information. If you want to programmatic access for this user, you can create an access key later on. What I'm going to do, I'm click on the next. Don't save. This is where you can set the permission to this new user. So either you can add this user to group, you can copy permission from something else, some other users, for example this user, or you can attach a policy directly. So these are the predefined managed policies by AWS. So basically you do have a permission. These are the permission which is managed by AWS. You can create a new policy, your own customized policy, or you can use an existing policy. Pretty much most of the usable access permissions are already defined. You can pick whatever you want. For example, if you want to give a administrator access, you can tick this one. Or if you want to give a S3 bucket access, let's say click on S3, you can see if you want to give a full permission on S3, you can click this permission. So what I'm not going to do anything because I want to show something. I do not add any permission. I'm click on the next. So this is a review page. What we're gonna do, I'm gonna create user. So user got created with the username and it shows password, and you can download these details. What I'm going to do, just click on the return to user. So if you haven't downloaded user password, if you continue, you can retry password in future. That's fine. I'll say continue. Right, so the user got created. What I'm going to do, I'm going to log to AWS console using this new user. I'll log into AWS console using the new user. As you can see, it's IAM user 1. I'll give a bit of increase the size so you can see the IAM user. So let's try to access EC2 instance. So let's say if I click on the EC2, what does it show? So it's give an API error. So basically you get this error because we don't have any permission. So if I go to S3, for example, S3, you can't see any S3 bucket, but I do have many buckets in my AWS account, but you can't see. So, and all this button, creating new bucket, copy RN and delete, none of them are enabled. So basically you can't create any bucket. That means you don't have permission. This is what's happened if you create a new user without any permission. What we need to do, we need to give a permission. Let's give some permission to S3 bucket, and let's come back to this console and let's see how things work. Right, so I'm back in my AWS console with the admin user. As you can see, I do have S3 bucket, but the new user is not able to see any S3 bucket. What we're going to do, we give a read-only permission to new user. Let's go to IAM, click on the IAM new user, and this is where you can add the permission. So click on the add permission. The first add permission is basically you can add AWS manage permission. On the second one, you can add a custom inline policy. We will do inline policy later. So in this scenario, we will add a permission. Click on the add permission, go to attach policy directly and type S3, do a search and click on Amazon S3 read-only access. So if you click on this plus mark, what you can see the JSON object. This is a permission. I mentioned the permission is a JSON object which say, okay, what are the permission or action defined in this within the JSON object. As you can see, it's come with a version. This is not going to change. It could change later, but this is a fix. And the statement. So a statement is an array. As you can see, under array you can add each object. Each object represent a permission. So it could be the effect is basically say allow or deny. In this case allow, that means it give a permission, and it says, oh, what are the action he can do. So in this case it's a S3 get object, all the get, it's a wildcard, all the list permission, list action, and plus it give us some lambda permission too, and the resource says okay, any resources. That's the permission object. What we're going to do, we add this permission to a new user. So as you can see, this new user got Amazon S3 read-only access. What I'm going to do, I'm go back to my IAM user. So I'm back in my IAM user. As you can see, I give it a refresh. So what I'm going to do, I'm give a refresh. So if I give a refresh, it should show all the buckets. Let it go. Let me give a refresh. Right, cool. Here we go. So this is a new user. A new user has a permission to access all the buckets. A bit smaller, so you can see the bucket. But if I try to create a new bucket, let's try to create a new bucket. So new bucket. test 1 2 3 4. This is a this should be unique. The bucket name, we will select Sydney and click on bucket. As you can see, it says to create a bucket you should have permission, the action S3 create bucket action permission. So in this case you don't have that permission, that's why it's given you are not allowed to, this new user is not allowed to create any new bucket. This is how work normal permission. So let's go to back into my admin console. We will do some resource-based policy and identity-based policy. What is identity-based policy? Right, so I'm back in my admin AWS console. As you remember, I mentioned under permission policy, there are two types of permission policy. One is identity, the other one is resource-based. So the identity-based policy, the one that we just added, which is called identity-based policy, because identity-based policy attached to principal. So the next one is a resource-based policy. Let's assume this is scenario. So we need to access, we create a new user, the one that we created, which is called IAM user 1. So, and we do have 9 buckets in my AWS account. So if this is my admin account, if I show you my new user account, he can access all 9 buckets. So we want to restrict accessing this, let's say we need to restrict this bucket. That's where we can use resource-based policy. Like if I'm go back to my admin console. So what we can do, we can create a resource-based policy attached to this specific bucket. So then the new user, the one that we mentioned, he can't access this bucket. Let's create a resource-based policy, then we will add to attach to this new bucket. Type of policies in here. The left side is a resource-based policy, the right side is an identity-based policy. So pretty much both policies are in syntactically same, except the resource-based policy come with the principal element, principal tag. So what is the really this resource-based policy does? It's restricting access to IAM user on this same bucket. So what we're going to do, we will go to apply, we will go and apply this resource-based policy and see this user can access this specific bucket. I'm go back to my admin control. As you can see, I do have a new file in the S3 bucket, and same way if I go back to my user account, I'm click on the demo resource-based policy, he can access this object. So what we can do, we go back to my admin console again, click on the permission. So I copy this whole bit and go back to bucket policy, click on edit and save it. That's all you need to do. We added the resource-based policy on into this new bucket. So let's click on this is a admin user, click on this bucket. Yes, he can list down he can see the object. Now let's go to a user account. I'm in a user account and go bucket, give a refresh, and let's click on the demos bucket. Right, if I give a refresh, you can see this new user is not able to see the object in this bucket. If I go to the other bucket, let's go to other bucket, for example this bucket, he can access the object in the rest of the bucket, but if I go to the bucket we added the resource, he can't access. This is how the resource-based policy apply. The role is a collection of permission. I'll take the scenario example. Let's say your application running on EC2 instance need to access S3 bucket and update a DynamoDB table. In such cases, what we can do, we can create a role with the necessary permission. So then the EC2 instance can assume this new role to do the manipulation in S3 or DynamoDB table. So this is not specific to EC2 instance. Once you create a role, even for the user can assume this role to do any necessary action on AWS account or a different AWS account. Let's try to create a role. I'm going to click on the role, and the first screen, it says trusted entity type. So the first scenario is, let's say you want to access same services in the same AWS account. That's where you can use the first option. Let's say you want to access a different resources in a different account. That's where you need to use the AWS, the second option. And it's pretty detailed. You can read the description and you can get an idea. And the same way, the other one, if you want to use some Facebook or Google, so you can create a role and the Facebook particular we can pass, and those federated login can assume this new role and do the unnecessary action on AWS account or services. So what we can do, we will create EC2. We create AWS first option and click on the EC2, and this is where you can add a necessary permission. Let's say we are giving S3 full permission to this role. Full permission. I'm not sure, a little bit slow. And let's say Dynamo DB table. Okay, we need to create. Okay, this is we are giving the full permission on Dynamo table. Click on next, give a role name, EC2 role, copy, and the step one. As you can see, this is the one of the permission which allow to assume the role, and then the second one is a permission. You can see this is a DynamoDB table permission and S3, so you can add tags as you need. Now let's create a role. It should create a role. Let's give a second. Nothing there. Let's click on again. Something wrong. Okay, creating a role in the background. Let's wait a few seconds until it's creating the role. And meanwhile, I'll go to role while it's creating and insert the role. Yes, the role got created. If I click on that, you will see all the permission which is attached. So this role can be accessed EC2 or any user. So that's about the role. We will do some demo using we will spin up the EC2 instance and assume this role in the later video. This is basically when I discuss with the STS token. That's where the STS token come to stage, and so if I show you the all in one video, so you will get better idea. Talk about the user group. User group is more about organizing your identity access management. So let's say you have 1,000 of users, they need a same set of permission. So it's really hard and time consuming to add each permission to each user. So what we can do, we can create a group, add those permission, then we can add each user to this group. Whoever belong to this group, they get the same set of permission, very easy to manage. So let's, for example, if I go to users, click on the IAM user, what I'm going to do, I'm remove this permission from this user. Then go back to user group, click on the create group. Says S3 bucket access group. I'm creating a new group 1 maybe, and I'm adding the new user, and then I'm adding the necessary permission. So read only. You can add more than one permission to this group, of course. So create a group. Its group is created, and under this group we do have one user, and this user has a permission on this, because now we don't need to add each user one by one. This automatically get this permission to this user through a particular group, as you can see, attached via a particular group. So if I want to add a, let's say you want to add a new permission, go to particular group, add let's say demo let's have a look, whatever it calls, add permission, sorry, add policy, dynamo something. Let's say we want to give a dynamo db read access, add permission. So we add the permission to group. If I go to user, this is one of user attached to particular group, so he get the same set of permission. This is very easy to maintain the permission in a large scale. This is where the user groups come. That's pretty much the demo. So we will do some more demo in the later, and hope you this enjoy, and let's get into next topic. We going to the next slide. What we're going to do, I forgot to mention inline policy. So what we're going to do, we create an inline policy. Let's say this user group, for this user group we need to give some permission to a specific bucket. So currently this group has if you go to the permission, it has a read only for S3 bucket. Let's say we want to give the right access for a specific bucket. So that's where we can create some inline policy. What we can do, we can go to add permission, create an inline policy. Right? Once you go to create inline policy, we select S3. You can use either visual editor, or you can use a JSON, just plain JSON editor. You can write your own permission. So I'm using the visual editor. So click on the S3, and what I am doing, I'm going to do only the write access and on specific resources. So we need to give a specific resource. Click on this resource, and what I'm going to do, I'm click on the bucket, and I give a bucket. So basically say I want to give a full permission on this new bucket. This is the exit bucket. Click on add. If I go to review my policy, let's say write access to this, and create policy. So it's create a policy and attach to user group. So if I see the current permission, as you can see, this is a custom inline. This is the inline policy you can create. And if I open the policy, as you can see, it's allowed, and these are the action they can perform on this is the resource. So basically whoever any user attached to this group, they can do write permission on this bucket, but they can't do write permission on the other bucket, only for this bucket. This is how you can add the inline policy, as I mentioned. Hope you enjoy. So if you have any question, please comment below, so I'll get back to you. So one of the topic I purposely missed, which is trust policy, I'm going to show in the next demo, which is more makes sense to go through the trust policy. Stay tuned. Let's go to the next side, which is authentication method. There are many ways you can access AWS system. So for example, you can use the username password, which is like a usual way of accessing AWS to the console. And otherwise you can use access key and secret, or sign-in certificate, and the fourth one is using SSH key. So I'm going through the couple of them in the next demo. This demo, what I'm going to show, how to access AWS services through AWS CLI using access key and secret. Then we can access EC2 instance using certificates. So let's talk about the first scenario. What we're going to do, we will create a secret key and access for this user, and we will configure that access key and secret to AWS CLI. Let's go to the user, go to secret credentials, and go to access key and create a new access key. So I'm going to use AWS CLI, I understand. Click on and create a user. So you can download these keys. Once you download keys, you need to go back to your terminal. So once you go to terminal, what you need to do, you need to run a couple of commands. So what the first command you want to write, AWS configure profile IAM demo. You can give a profile name as whatever you like. So this will end up with asking access key ID. This is where you need to give your access key and a secret, the one that you download. I give my access key here. This is the access key ID, and my then I give my secret. Give your southeast to. This is your default region, in my case default region, and give it output as a JSON. This will configure AWS CLI, and you can access these credentials. You can access, you can use these keys to access the AWS service. Right, so now we configure our AWS CLI. If I try to access AWS service, let's say AWS s3.ls, more likely you get the error, because the reason is we create a profile but it's not a default profile. So if I run the AWS s3.ls, it's trying to get something a default profile. So if I show you the aws.aws folder in your user profile, it create a config and the credentials two files. So I'll show you the two files. So the config file is something like a profile IAM demo, the one that we created. This is a config, and if I go to credentials file, it's okay. It's the same profile name with the access key and access key and access a secret. So this one, the command, the CLI command, the terminal, it's looking for something default, because this is not a default. So what we're going to do, we can create a kind of, if you want to create just one profile, if I run in the same command, if I configure, and I'll give the same name. If I go back, oh, sorry, it's wrong. If I again, I'll give the same secret ID and access ID. Default profile, default region AP, south is to JSON. Then if I go back and if I try to s3.ls, it's list down all the bucket. The reason, if I show you the config file and the credentials now, what you can see something default, right? So if you do not provide any profile over here, it's pick up the default profile. Like if you even for the credential, there's a default profile, because in this case we are using same key and access secret, so that's why it's the same ID. Like what you can do, you can use either one. So for example, if you want to use the same one, you can say profile. If you want to use the IAM, what's the name? IAM demo. So if I use IAM demo profile, IAM demo, you can access. Okay, you need to say 2 dashes. Then you can access the S3. So this is how it's working, because in the CLI, if you do not provide a profile, it's picking the default. There should be a default profile in your config and credentials file, right? Let's keep it this one, because we use default. We don't need to put profile every time. So this is how you can access your AWS services through access key and secrets. You can add as much as a profile into this config file. Either you can add manually, or you can use AWS the command I wrote, which is called AWS config and -- profile. So there are 2 ways you can add the profile into here. So this is how you can access AWS service. Same thing, it's not this is simple command to list down all the bucket in S3, but you can do all the pretty much every operation through CLI. Right, now let's go to we will create a EC2 instance and try to access EC2 instance through using the certificates. In the AWS console again, so I'm typing EC2, search EC2, go to EC2 screen, create a currently we don't have any instance. I'm going to launch a new instance. I'm going to change it to Sydney and click on launch. So this is EC2's name, demo EC2, give it a name and keep it as everything in a free tier. So you can see Amazon Linux, it's under free tier, and instance type is T2 micro. It should be okay, and create over there. This is something you need to create a key pair. So what I'm going to do, I'm going to create a new key pair, and this says demo EC2 pair and a download. This will download a new key pair. So this can use to this is the file we're going to use to access this EC2 instance. So if you go further down, you need to create a security group, or because we need to do the SSH into EC2 instance. I'm giving allow to access and do the SSH from anywhere because I'm gonna delete this EC2 after this video, so it's not gonna have any security issues. Keep it all the configuration as it is and launch. This will launch EC2 instance. I'm going to all the instance and let's have a look. It's still pending. Let's give it some time. It will come up in a few seconds. EC2 instance is up and running. As you can see, this is running. So what I'm going to do, I'm open my terminal and I copy the give me a sec. I copy my pem file, the one that I downloaded, into this folder, and I'm going to access this EC2 instance. How I'm going to access, this is a command you need to write. So you need to copy the public IPv4 DNS. So then this write the command. So basically what you can see, I'll make it a little bit bigger. SSH, I'm going to SSH and give a file in -i and give a file name. In this, as you can see, my file is demo ec2 pair.pem, and then the username. So what you can see, normal EC2 instance user, there's a user called EC2 user, that's a username, then add, then after that the public endpoint. So basically in this case you can see this is the same one over there. So once I'm done, I want to show you some errors. Basically most people get the same issue. So it says as you can see, it says authentication is host blah 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 can't be established. This is known by the other name, and says I want to continue with the connecting. Yes, if we say yes. Right, so this is the error you see. The permission for this is to open. So most people get this error. What you can do, this is because the PAM file doesn't have a permission to execute. What you want to do, you want to change the permission of the PAM file. This is a change. I'm going to change the permission. And then what I'm going to do, I'm run the same command again. Right, so as you can see, I'm successful login to EC2 instance. If I run, yes, as you can see, this command, my PowerShell, the sh window, it's in the EC2 instance, which is already there. So you can see 172.31.15.24. That's the IP address. If I go up, that's a private address of the EC2 instance. You can see 71.31. So this is how you can access EC2 instance through certificates. So hope you enjoy, and let's move to next. Right, the next topic is STS. STS stands for Secure Token Service. which is responsible for creating a short-lived token. For example, let's think about your application running on EC2 instance which need access to S3 bucket. But usually the EC2 instance does not have permission to access S3 bucket. That's where we need to use a role. What we can do, we can create a role assigned to EC2 instance, and the EC2 instance assume that role to access S3 bucket. That's where the trust policy gets used. I'll show you in a image, in a diagram, which will make more sense. As you can see, we do have an application running on EC2 instance which need to access S3 bucket. But what we can do, we can assign a role to EC2 instance. Then EC2 instance assume that role to access S3 bucket. What's going to happen? As I mentioned, the role has a trust policy and the permission policy. The permission policy says, okay, what are the resources they can access, what are the action they can do. But trust policy says, okay, who can assume this role. So as the example of the trust policy is something like this. I'll show you in the console in a bit. So it says effect, it's allow, and the principal says, okay, this is the principal, all the EC2 instance in AWS, and the action is STS assume role. So basically, whoever access this role, they can assume. So in this case, we need to add the service. For example, if you want to, let's say there's another, let's say it's Lambda want to access something, we need a new role or something, or same role. The service will be the Lambda on AWS. So that is something happen. What's going to happen? We assign the role, and the EC2 instance, what does it do? It's called the STS to get the temporary token. It's request a token because the EC2 instance assume this role and request a token from the STS secure token service, and the secure token service provide a temporary token. That's the token the EC2 instance used to access S3 bucket, which is temporarily. The token get auto refresh time to time by AWS. You don't need to worry about. So that is how EC2 instance can access S3 bucket using the STS and some assuming particular role. So let's go to the AWS console, and we will do this in a demo. I'm in the AWS EC2 instance screen. So this is the instance we created earlier with the last demo. What we're going to do, we're going to create a new role. So then we can assign that role to this EC2 instance. What we're going to do, go to role and create a new role. This is AWS service, select the AWS, and the common use case says EC2, and go to next. And we will add S3 full access. Try S3 full access. Next, and you can give it a name EC2 S3 full access, maybe full access role. Copy that, and as you can see, when you create this role, this is the trust policy. The trust policy says whoever use this role can be assumed by this service. As I mentioned, this service could be, we can use this role to different services. It could be Lambda, it could be DynamoDB table, or anything. So as far as the particular service is there, they can assume this role. And the permission, this is the permission policy. So this is a trust policy, this is a permission policy. And the permission is basically say access S3 S3 full access. So I'm creating a role. It's creating the role, and come to role, and yep, so our role is there. I'm go back, and permission is there. And if you go to trust relationship, so the trust policy is show under trust relationship. This is something we created. Right, let's go to now our EC2 instance, because this is the instance is already created. What we can do, we can attach a new role to this EC2 instance. Before go to this instance, attaching this role, what I'm going to do, I'm going to log into my EC2 instance. Yeah, I'm in this instance. If I'm trying to s3.ls, I want to show whether it can't access any S3 bucket. So you can see you need to configure your credential, otherwise it doesn't have any permission. So what I'm going to do, go to select the EC2 instance, action, go to security and modify IAM role. So here we can update our role. So we can select our role. We just create S3 full access role, update role. So we attach successfully the role the created into EC2 instance. If I go back to my EC2 instance and if I try now, yes, you can access all the AWS S3 bucket in here. So this is just a list down the bucket. The same way you can do any manipulation. You can upload any object into S3 bucket because the permission is already set up for a particular role. This is how you can use a role, assume a role to access other AWS services. In this case, what we use EC2 instance, you assume the role. So same way we can use a particular user can assume a role to access any AWS services. So that's how that's about STS and trust policy, sort of all the theories we covered in this demo. And let's move to next. So the instance is running, it's going to cost if you keep running in your AWS account. What you need to do, you need to select the instance, you need to terminate the instance, otherwise it's running forever and you will get a cost for you. So yeah, please do delete whenever you finish this demo. And for service control policy, the SCP is a big topic in the AWS Solution Architect Pro exam. So please keep your attention if you are going to take this exam. There will be a couple of questions on the exam definitely. Where do we can use SCP? SCP can be used to control the permission in a AWS account level. Let's say your organization has a multiple AWS account and you need to apply some restriction to certain accounts. That is where you could use this SCP. I have put the AWS documentation for the SCP, so you can refer for more info. Let's see this all in a diagram. For the diagram, SCP comes with a concept called organization unit and a root account. This organization unit can be used to group the AWS account. In this case, this organization have a few AWS account, like and plus we do have a few organization unit 1, 2, 3, and each organization unit comes with some AWS account attached. Let's assume we need to restrict S3 write access on a few account A or account B. What's going to happen, we can attach this, assume this is the SCP policy, we can attach the policy into organization unit 1. What's going to happen if you attach this SCP policy to organization unit 1, it's applied to account A and account B. Same way it's applied to account C, because organization unit 2 under organization unit 1. The specialty of the SCP, if you add the SCP to account, which is root, so it's all the children underneath get inherit all the restriction. So if you want to restrict the S3 bucket write access on X and Y, you can attach this policy into SCP unit 3. That's how it's work. So now let's go to AWS console and see how these things working. AWS organization main page. If you want to navigate to this page, what you need to do, you need to type AWS organization and click on the AWS organization, the first link. So once you click, it's come to end up with this screen. So as you can see, it shows the root and your AWS account, the one that you log in. So what you can do, you need to add other AWS services. How do you add the other AWS services? you can click on the add an AWS account. So let's click on the AWS account. The add an AWS account. So of course you can create a new AWS account, or you can invite to an existing AWS account. Usually this is happen, you are inviting to existing AWS account. So what you have to do, you put your account ID, the other account ID, and give a message to the recipient, and then you can send an invitation. What I did, I sent a sample invitation to one of the AWS account. So if I go to the invitation, so you can see this is invitation I sent, and the status is open. What the other account holder has to do, they have to accept this invitation. They come with the accept, they can accept this invitation. Then whenever it's accepted, we can add that new account into organization unit. So let's see how do we add the unit over here. What I'm going to do, I'm click on the root, because I'm going to add a unit to root. So go to action and create new. Once I click on the create new, it will end up with the place you can add a organization unit. So as you can see, this is organization unit one, and yeah, that's all. Just click on create organization unit. Create unit. So as you can see, it's got created under root. So same way you can add another unit to under root, or you can add a unit to under unit one. So for example, if I go to add in another one, click on the unit one, go and create a new unit. Be unit 2. Unit 2, and create organization unit. In unit 2 got created. So what's going to happen? So if you do have a AWS account, any other AWS account, the one that we send the invitation, if they accept, so you can add the organization unit in, so the particular AWS account into this unit. That's how you can add the SCP work. So let's go where's the actual SCP defined. Let's go to the policies. Click on the policies. As you can see, it's come with some of the policy type, supported policy type it shows, and this is the service control policy which is currently disabled. How do you enable? So you click on the service policy and enable service control policy. Let's wait, and by default it's create some AWS manage policy attached, so we don't need to worry about this. Is used for internal purpose. So what we're gonna do, we will we will add a new a service policy over here. What's gonna do, as I mentioned, we will create a new policy which restrict S3 write access. How do we create? We create a new policy. Click on the new policy. We can say S3 write access. Maybe say this is we're gonna deny, and you can give a description. Go down, and this is where as you can see, this is a template for the SCP policy. So it says effect already defined as a denied. So very cool, right? What we're gonna do, we say we can use this editor to find the service. We can say, or otherwise you can update the JSON directly. What I'm saying, I select the S3, and I say okay, let's give all permission, all action. So all action denied, and for the resources, then we need to select the resources. Which resources? If we go to if you scroll down a little bit, you can add the resources over here. What I'm going to do, I'm select the S3 and all resources, all the S3 bucket gonna be impact on this SCP policy. I click on the add resource. Right, it's pretty much this is a service SCP policy we created, and what we're gonna do, we need to give a name. Yeah, already give it name, and what we're gonna do, we click on the create policy. Right, these are the service policy. Currently it's in the in the AWS organization. What we're going to do, we can go to the AWS and select the unit and attach this the particular policy. AWS account main page. What I'm doing, I'm going to select unit 2 or unit 1. Let's do we go to unit 1, attach a SCP policy. What we're going to do, you can go inside the unit 1. This is unit 1, and go to policies. It says this is the children. Of course, this is unit 2, and if we do have a AWS account attached, it shows all the AWS account underneath. So what we're going to do, go to the policies, and as you can see, it's AWS full access is already there. So what we're going to do, we're going to attach a new SCP policy. Select the policies and attach. Right, so now the unit 1 has a SCP policy attached. So what's going to happen, any AWS account under this unit will get this permission. So it's denied the permission to access S3 bucket. So that's how the SCP work. So this is as I mentioned, this is one of the questions. A few questions come in the AWS Solution Pro exam. So stay tuned. Try with if you do have more than one AWS account, you can try with the same way I did, but in this case I haven't used the second account. So please follow the instruction, and you will be in a great position to answer any question regarding the SCP. So hope you enjoy this SCP, and the next topic is other one which is really interesting, which is permission boundary. Let's move to permission boundary. It's a permission boundary. Permission boundary is a policy which avoids to do a privilege escalation. Let's say if the user has a permission boundary attached, this user cannot create another user without adding the same permission boundary. The same way, the user cannot create another user with more privilege than what he currently has. Right. As you can see, the same scenario in the left side without permission boundary, in the right side with permission boundary. Let's focus on the without permission boundary first. The user John, he has a IAM full access, but he doesn't have any access to EC2. When the John is trying to access EC2, it's get denied because this is expected because he doesn't have any permission to access EC2. But what John is trying to do, he create a new user called Sandra and assign admin access to Sandra. This is perfectly work because John have a full permission on IAM full access. Then John can access the EC2 through a Sandra's login. So because Sandra has admin access, he can perfectly access EC2 instance. So this scenario is a without permission boundary. Now let's go to the with permission boundary in the right side. The same scenario, but in this case, John has a additionally permission boundary attached. He has IAM full access, doesn't have access to EC2, but he has a permission boundary attached. When he's tried to access EC2, as usual, he gets denied. But still, John can create a new user called Sandra and assign admin access. That means full access. But when he's tried to use Sandra login and access the EC2, he gets denied. That's because the permission boundary attached. So as I mentioned, permission boundary avoid privilege escalation. So let's go to the AWS console and see how these things working. Right, so I'm in the AWS console under Identity IAM service. What I'm going to do, I'm going to create a user called John. Let's create a user called John and enable console access. Give a password, and I don't need to change the password in next login, John, and click on next. I don't save the password. What I'm going to do, I'm attaching the IAM full access. So as per the previous scenario, what I'm going to do, I'm adding IAM full access to John. Click on next and click create user. The user got created. I get the username password. What I'm going to do, I'm gonna open a new window and log in as a John. Right, I'm in an AWS console using my new user who called John. As we create a user called John, and this is a John account, John login. So what I'm going to do, I'm going to access EC2. So if I try to access EC2 as a John, he cannot access any EC2 instances. Let's go to the IAM. If I go to the IAM, yes, for the John can access any IAM service, and he even can create a user with the admin permission. What I'm going to do, I'm going to create a new user called Sandra. Sandra, enable username, give a password. This is password, and yep, untick and create next. What I'm going to do, I'm attaching admin permission. John is trying to attach admin access to Sandra and create a user. Right, perfectly created. So user got created for the Sandra, and what I am going to do now, John can use Sandra's login to log into the AWS and can access EC2. That's something I'm gonna show in the another browser. So what I'm going to, I'm copy this one. Log into AWS console using a Sandra. Now I am referring Sandra. So for the Sandra, if I click on the EC2, what we can do, Sandra can access any EC2 instances, or he can have access to IAM service, and even he can create a new user. So pretty much he has all admin privilege. So this is something we're gonna avoid using permission boundary. So now let's add the permission boundary into John and see the new user can access EC2 instance. Right, so I'm back in my admin account, and let's see where do we add the permission boundary. Let's click on the John and scroll down, and you can see the permission policy, and we do have another section called permission boundary. John has a IAM full access as a permission, but currently we don't have any permission boundary attached to a John. So this is where we are creating a new permission boundary. So let's have a look. How does it look like a permission boundary? Right. So as I mentioned, the permission boundary is a policy. It's a JSON object, and this is one of the permission boundary we can use. So for example, as you can see, we do have a few statement, a few object under a statement array. The first object says, okay, this policy allowed a full permission on IAM. It says asterisk wildcard with IAM, all the action on IAM. So the second one, it says you can't create a user without, or you can't create a user without a particular a permission boundary. So basically what we're gonna do, we're gonna create a permission boundary policy called permission boundary. This policy name should be same as this. If you change the policy name, it should be you need to replace over here the same way the account ID. So you can see this is the account ID, and this is the policy name. And the second object, the third object, is says you cannot delete a policy. So once you have a permission boundary attached, you cannot permission boundary policy. The other one, again, you can't edit or you can't remove any permission boundary from the users or all if they have. And the lastly, what you can see, you can't update. It's the same way you can't delete, same way you can't update permission boundary. As you can see, this is a condition. You pretty much you need to focus on the condition. This is called permission boundary, and the policy I'm going to create a name is called a permission boundary. So as I mentioned, if you create a policy called X, you need to replace with the X wherever it's a permission dash boundary, and you need to change the account ID. I attached this file into in the description in the video. Right, that's how the permission boundary policy. Now let's add this permission boundary to John, the user called John. I'm back in my admin console. What I'm going to do, I already select John. What I'm going to do, I'm gonna create a set the permission boundary. Click on that, and what you can do, you can select the one that existing, or you can create a new one. In this case, what I'm going to create new one. I copy copy and paste the whole JSON file I'll show you, and make sure the policy name it's a name as a permission boundary, or if you change the policy name, you need to replace this name. So go to next. What I'm going to do, and I don't need to add. So name is permission boundary. This is the name, as it should be same as the one that in the content, and create policy. Entity already exit. Okay, seems like I create a policy already. What I'm going to do, I'm gonna delete the existing one. Pretty much same thing I'm gonna create again. That's fine. I'm gonna create again, just to copy JSON, paste everything, copy the bound name, go to next, keep this name as a permission boundary, and create a policy. Right, so the policy got created. I'm go back to my John. Let's go to John and go to the permission and set permission boundary. And this is where you can search the one that you created, the policy you created. Select and set boundary. Right, so everything is get set up. As you can see, permission boundary got set up for the John. Now let's go to John account and create a new user, and see new user has a permission to access EC2. Right, as you can see, I'm back in John account, log as John. So what I'm going to do, I'm going to create a new user. This time we call it sender2. Enable console and give it a password. Make sure it's a 321 John. Yep, and untick and click on next. And then as usual, as earlier, what I'm going to do, I'm going to add admin access to a sender2. It's perfect fine. And then what I'm going to do, I'm going to create a user. So as soon as I click on the create user, as you can see, I get an error. It says John is not authorized to perform create user on resource, the new user, with the explicit denied on permission boundary. So this is where it's apply the permission boundary. You cannot create a user without adding this permission boundary. So what we need to do, if you go back and the new user, I'm going to create a new user sender2. What you have to do, you need to set the permission boundary. So what you need to do, you need to search the same policy. I search it and select. Now what you can see, this user got a permission boundary attached. Now what I'm going to do, I'm going to click on the create. So yes, it's perfectly create the sender 2 with the permission boundary attached. So it didn't allow to create a user without adding a permission boundary. That's keep in mind. What I'm going to do now, I'm going to log as a sender 2 and check whether the sender 2 can access EC2 instance. I'm back in my AWS console. This time, as you can see, I log as a sender 2, the second user I got created. The John created this sender 2 with the permission boundary attached. So let's try to access EC2. Right, so as you can see, we get an API error. That's been authentication error. You cannot access EC2 for as a user sender because sender 2 has a permission boundary attached. If I try to go to IAM, come on, so it's go to IAM, yes, and if you go to users, even for the sender 2, he can access IAM full access because John has a IAM full access. Whatever the access John has, it can be used for the sender 2, but sender 2 can't get the higher privilege than John. So for example, even for the sender, let's try to create another user. Let's say sender 3, copy. Please make sure we are log as a sender 2. He's gonna create another user to give a admin permission. Let's try to create a new user. Click on next, and let's give a admin permission. Yes. Click on next and create a user. So again, as you can see, so even for the sender 2 cannot create a new user without adding a permission boundary. So as far as he added the permission boundary, she can create another user. So let's go permission boundary and create a user. Yes, perfectly, it's creating the another user, but they can't escalate the privilege. So whatever the privilege the parent has, it's inherit to the child. Child cannot get more access than the parent. So that is pretty much what is permission boundary. It's as I mentioned, it's avoid a privilege escalation, and this is a good way to use in AWS if you need to control some permission. So hope you enjoy this video, and as I mentioned, if you get any issue or while doing the demo, so please comment below. Now the next step, let's go to the cross account access and see you there. Cross account access is another topic comes in the AWS solution exam. What is cross account access? Cross account access is something like a user in one AWS account access a resource in a different AWS account. Of course, it's involved more than one AWS account. As per this diagram, we do have a user called John in AWS account A, and there's a S3 bucket in account B. Let's say John wants to access S3 bucket in account B. How do we achieve this? The very first thing what we need to do, we need to create a policy in account A which attached to John. The policy should allow assume role permission. Then go back to account B. We need to create a role in account B which has a trust policy and the permission policy. What does the trust policy should allow? Assume a user in account A. Then the permission policy should allow accessing S3 bucket. As far as we do have a policy setup and the role setup, the John can assume this role and access this S3 bucket. So this is a scenario what we're going to achieve. So now this is a theory. Now let's go this in action. I'm back in my AWS account A. Currently I do have two users.
And what we're gonna do, we're gonna create a user called John as we discussed in the previous scenario. So before go and create a John, so what I want to show you, one of the in my CLI, in AWS CLI, if I type AWS S3 ls, it's list down all the bucket. That's been if you go to account A, these are the bucket it shows, account A, and pretty much it's list down the account A. So then if I run the another command which is called AWS STS get call identity, I'll bigger, make it bigger. So what's going to show, it's currently what's the user it's configured to access AWS account. So as you can see, the ARN is Sam. So this is the second user currently in my account. So what we're going to do, we're going to create a John. I'm clearer and gonna create a John and attach the policy as we discussed. Let's click on the add user John, enable the custom, give it a password, and click on next. Then what we need to do, we need to attach a policy. So as I mentioned in the previous slide, the policy should allow to assume a role. So what we're going to do, we're going to create a new policy. Click on the create policy. It will open a new tab. In the JSON, go to the JSON and copy this policy. So this policy is basically it's allowed assume role to all resources. So STS assume role because the John assume a role in account B as we mentioned on previous slide. So give it this permission and keep the name as a okay, no need to add a tag, no space, make sure no space, copy cross account policy. This is a policy name and click on the create policy. This will end up with creating a new policy. Go back to my other tab where I was in the middle of the creating user and search the policy just I created. So paste it. I just need to give a refresh otherwise, and then try that. Yep, the policy is there. So what we're gonna do, we're gonna create a click on next and create user. So user got created. This is John, and what we're gonna do, go to our return list, and we need to get the access key for the John. So basically we're gonna configure our AWS CLI with the John credentials. Go to security credentials, go for the down and click on create access key. I'm going to use the command CLI and click on understand. I'm understand, then create a key. So let's download the account key. So account key got created. What I'm going to do, go to my CLI. Either, as I mentioned, either you can use CLI tool to configure your AWS new profile, or you can update the credentials and config file. So let's create a new profile and let's give it a name. So what we're gonna do, we're gonna configure a new CLI profile. So give it a name as a John. Asking, let me open the file. Yeah, it's asking access key. Let's get the secret and default region. We get AP Southeast 2 and give it a JSON. My AWS CLI is configured for profile John. What we're gonna do, we can call the STS token get identity, and you can give a profile name. So if I use a profile name, yes, it's using the John now. we do have a default profile and another profile called John. So what we're going to use a profile called John for the rest of the work. So as I mentioned in the first slide in the first left side, which is account A, it's already configured. We create the John and we create the policy. Now let's go back to account B and create a role and create a bucket over there. See, I am in account B, the second account. So I already create a S3 bucket, one S3 bucket, and give it a name as a code my bucket. And as you can see, this is my second AWS account, which is account B. So what I am going to do, as I mentioned, we're gonna create a S3 bucket. Already I created, and then we're gonna create a role. So let's go to a role and create a new role. So go and create a role, and in this case this is, as I mentioned, when you create a role you need to give a trusted policy and the permission policy. The trusted policy where it says okay, who can assume this role. So in this case this role will be assumed by the account A. Therefore we need to select the AWS account, the second option, and go to the second option, which is another AWS account. So you need to give an ID of account A. So as the console is currently account B, in here what we need to give a account ID of account A. So I already have an account ID of the account A, and then there's an option called, you can go the require MFA. Whenever you access this role we need to give a MFA, or there's another concept called external ID. The external ID is something you give a kind of secret string. Whenever user in account A want to access account B or assume this role, they should provide this secret key. So let's give a secret key as a external ID as a loud code dash ID. So you can give any ID, but make sure I'll provide all the code to create these roles and permission. So make sure whenever you change the permission on external ID, so you change everywhere as needed. Right, let's go to and click on next. So we create the trusted policy. Now we are going to permission. So in the permission, what we're going to do, we give a S3 full permission. Go and click on next, and the role name, what we can go, we can give a role as a cross account role. This is a name of the role. You can give a description. As you can see, trusted policy, as you mentioned, as you can see, so the trusted is, it says this is the account ID of account A, and it says whoever try to access assume this role, they need to provide this external ID. So the already permission is added. It's give a S3 full permission, then click on create role. So yes, the role got created, and we do have a S3 bucket. Everything is set up in account B side. Now what we need to do, we need to go to AWS CLI, the command line, and try to access this S3 bucket using this role. And if I type AWS STS get caller identity, so as you can see, it's my default user, which is Sam. What we need to do, we need to use John. So let's try running this command. What we need to do, we need to run this command. So what does this command does? If I go back, let me show you. It says we are assuming, we are calling the STS and assume role. The profile is John. We are using the profile John, and the role ARN will be in the role of the account B. This is the account B account ID, and this is the role of enroll in the account B. And then what it says, let me check the rest of the code. So I'll show you in the code, then it's make more sense. If I copy, right, so this is the command I'm gonna run. So if I make it bigger to make sure everything is perfect. Right, basically if I run the sts command, this is a command I ran first. The second command, we are using the assume role, the profile John, and the role ARN. This is the role ARN of the account B, and the this says role per session name, AWS CLI. I'm using the AWS CLI session, and external ID. This is where you need to give the external ID, which is we created under role in the account B. So as far as you run this command, what's going to happen? It's returned some information. This is the temporary information. As you can see, it's create a new access key ID, secret key, and it's give a session token. So what we can do, we can use this information to access S3 bucket. So let's try what we need to do. We need to go here and we need to export these keys. The first one, session ID. Then what we need to do, the second one is secret. Just copy and paste here, and the third one is session token. Session token equal, what we need to do, we need to copy the good big string. Then so export is, but what does export command does, it's basically export these keys into environment variable. Whenever you use AWS CLI, it's check is there any keys in environment variable, then it's use that variable, otherwise it goes to and check the config. So this is done. What we're going to do, if I try now AWS S3 ls, yes, you are accessing the S3 bucket in the account B. So if I run the STS token get call identity, and this is different. So now what you can see, it's using assume role, the cross account role. So currently the command line or AWS CLI in a terminal which use cross account role for this session connect to the database, connect to the AWS account. So that's why if I run AWS S3 ls, it's written in the S3 bucket in account B. So this is how you can access one resources from another AWS account. So you need to create a role and give us some permission as needed. So hope you enjoyed this video, how to access the cross account access. And what you need to do once you finish this, you need to run unset command. So basically what it does do, it's removing all the keys, key ID, secret, and session from the terminal. So I unset, and if I run the AWS S3 ls again, what's going to happen? It's connect to my AWS account A, and the user gonna be a default user, which is Sam. So that's how you can do this lab. And if you have any question while doing this lab, please comment below. I'll try to help whenever as soon as possible. Right, thank you so much for your time, and let's move into next. Right, so RBAC and ABAC. RBAC is a role-based access control, where ABAC is an attribute-based access control. So why do we need access control? The access control are used to allow or control the permission. I have mentioned the AWS doc link, so you can go and have a look for more information. So let's go to the demo in the console, AWS console, and see what is RBAC and ABAC in action. Right. So RBAC is pretty simple, which is role-based access control. We already have done, but I'll show you as a reminder. So let's say we do have a user called John, and John has some permission. Currently he doesn't have any permission. What we're going to do, we're going to add some permission. So let's go to attach policy from directly. Let's say S3 give access. It's give a S3 full access, nothing else. So add permission, and yep, John got a full permission on S3 buckets, so nothing else. So then what I'm doing, I do have a John logged into account, the same account, and as you can see, this is John. And if I go to bucket, yes, he can list down all the bucket. He has a full access on object even in the bucket. So if I go to another bucket, let's say go to another bucket, so he has a full permission on the bucket. He can upload, he can see, he can delete anything. But if we go to the EC2, he doesn't have any permission because there's no permission allowed to access EC2. This is called role-based access control. Now let's go to main AWS account, then let's see what is attribute-based access control, which is more interesting. Back in my AWS console with the admin user login. So what I'm doing, I'm removing the full permission on AWS S3 full access from the John. And then what we're gonna do, we're gonna go to user groups and create a group. So I'm creating the group, let's say demo group. Click on the demo group and add the John. And what we're gonna do, we're gonna let's create the policy later. So just we don't need to attach any policy, just create the group. The group got created. What we're gonna do next, create a policy. This is the attribute policy based policy. We're gonna create attribute based policy. Click on the policies, and let's create a new one, the fresh one, the custom one. And the JSON, in the JSON, what we're gonna do, I'll copy the JSON and we will go through. So this is a permission. So what does it says? You can change anything. The seed ID, it could be anything. So it's allowed on the action is S3, any action on S3 for any S3 bucket. And based on the condition, this is a condition. So it's a condition says, as far as user principal, it says AWS principal tag. There's a tag called group. The value of the tag is an admin. Then it's allowed to access any S3 bucket. That's the whole idea of this. This is called attribute based condition. So what we're gonna do, we need to add the tags call group. The actual value should be admin. So whoever has a tag with the admin group and the admin, they can have a full access, otherwise they don't have any access. So we create the policy. Let's click on the next. We don't need to add tags. Let's give a name. This one let's call policy ABAC. Copy, create policy. Policy got created. And then what we're gonna do, we're gonna go to groups, demo group, and let's add the permission. So nothing there. I guess it's a cache. What we're gonna do, we find the policy, just what we just created. It's a policy ABAC. Come with the same one what we push, and add permission. So in the summary, we create a group, we add the user John, and add the permission. The permission has some condition, right? So if you go to user, actual user, if you go to John, so John doesn't have any direct permission. So this permission come from the group, right? Even the John doesn't have any tags. So what's going to happen in these cases? If I show you the John account, this is a John account, as you can see. If I give it a refresh, nice refresh, and if I go to S3, so probably it should give an error. You can see it says no bucket at all. Like if I go to refresh again, he cannot see any bucket, right? So what we're gonna do, go back to John, and we're gonna add a tag. So remember the permission, in the permission we do have a tag called group. What we're gonna do, go to John, click on the tags and add new tags. Add new tags. This is a group, this is a group, and value is admin. Give it a save it, group and admin. So it's matching the permission a condition. So now let's go back to my John account, give it a refresh. Here we go. So John now can see all the bucket, and he has a full permission on the bucket. So as far as if I go and change the go back and change the tags, let's say I'm changing the tag into user and save it. Now John has a tag, the key is group, the value is user. So if I go back my John account, give it a refresh, here we go, he can't see any bucket. This is how you can use attribute based policy or access control to limit the permission and do some customization. I'll show you the permission again. Go back, and this one you can do any action. You can customize the permission, customize this statement as your requirement. So that's about the RBAC and the ABAC. So hope you enjoyed this video, and see you on next video. That's all about AWS IAM. Hope you enjoyed this video and got something out of it. Thanks for spending almost 1.5 hours here. And if you have a comment, queries, please comment below. I will get back to you as soon as possible. Again, if you enjoyed this video, please like and subscribe. Really appreciate it. See you on next video. Thanks.